OMIS 351, Unit Number 3, Information Technology Foundations, Part 1, Hardware and Software. Where have we come from? Unit 1 was an overview of solving business problems with information technology solutions. Unit 2 was 7 lenses and other strategic frameworks to decide if a Unit 1 business idea was beneficial to our organization. And Unit 3 now says, okay, we're going to make these matches. We need to start learning about some of these information technology solutions. We've learned about some, we've talked about some. Now we're going to learn specifically about various pieces, and we begin with hardware and software. So when you look at your participation quiz, just covered that. We say, what are some of these solutions? What are some of these technology solutions? How does hardware and software work? How can it help solve my business problem? Here is a schematic of how a computer works. It takes stuff in, processes it through a CPU, sometimes referred to as the brain of the computer, and it gives stuff out to us. Market leaders here: keyboard, mouse, a microphone, voice recognition. We're getting information in. Market leaders here: the screen, your computer screen, your phone's screen. Printers. Printers are being used less and less because of the cost of ink and paper. We try to use them less frequently to save money, but they're still most certainly an output device. Secondary storage. Most popular is the hard drive of your computer. Similarly, a flash drive, a USB drive, a jump drive. People call those things different names. That's the same thing. Those are secondary storage devices. We want to store our marketing paper, our Excel spreadsheet, the work that we've done, our intellectual property. Then within the computer, the control unit makes sense of the ones and zeros. The arithmetic logic unit, ALU, makes comparisons and does the math. Is this greater than this? Is this less than this? Etc. And primary storage is more easily and quickly available storage. So it's faster than this. At the end of the day, from a high level, you need to understand that computers are only better than humans at two things: processing ones and zeros incredibly quickly and remembering ones and zeros almost perfectly. The genius of a computer is simply the on-off pulse of an electrical signal. That's sometimes referred to as binary state, a two-state system. The electrical pulse is either on or it's off. Quite simple, right? From there, the on-off pulses were represented as either a 1 or a 0. And the genius, why computers are so wonderful, is because they rip through those ones and zeros. They can process them at speeds that our brains cannot really comprehend. And similarly, if you have a 120 gigabyte flash drive, it's very unusual when you'll go to pull up a file and it's not there. It does happen, and you need to be prepared for that. We'll talk about that in the next unit. But it's very unusual. So the computers are very fast at processing and very good at remembering. Beyond that, we, the humans, make them do what they do. If hardware, which is the physical parts, the computer itself, the screen, the physical side, if the hardware is going to solve business problems for us, it's going to need really good software. Software is the set of instructions that this brain of the computer processes to do something. Add up a column of numbers, draw us a graph, connect to the internet. Whatever the task is, the ones and zeros are doing it through instructions given by software. So that's what hardware and software is. We want to get going. That's the inside kind of a computer. Here's another picture of the inside of a computer. This green thing, the green bottom, is called the bus or the motherboard. That's where everything is connected. There's the CPU. You can see this one is made by Intel, who is the market leader in CPU or chip processing and production. So that's connected to the motherboard. We have expansion cards. There's the hard drive, the biggest secondary storage. We have CD and DVD drives as input and output devices. And over here we have random access memory, or RAM. That is a primary storage connected to the motherboard, faster access for storage. So if you want to store little bits of things so the brain can access it quickly, it's faster to get it from here than from here. The analogy I use is if you were on client calls all day, the RAM, how much RAM you have, would be analogous to the size of your desktop. So in other words, if you were accepting many different calls, one came in, you put somebody on hold, you talked to somebody else, and you wanted to see the client files of multiple people simultaneously, you would set those files all on top of your desk. And so the bigger the top of your desk was, the more of that you could do. Similarly, the more RAM you have, the more multitasking you can do. You might want to be connected to the internet, watching a video, listening to a podcast, doing a spreadsheet all at the same time on your computer or your phone. And if that's the case, you would want a larger amount of RAM. The hard drive is like the big file cabinet in your office. If a different client calls, whose folder is not on top of your desk, you could still walk across the room, pull it out of the file cabinet, and then open it and talk to that client. The only difference is that would be a little slower. Similarly, the computer has to go over, access the information, and bring it into an area where you, the user, can work on it. So that's been a pretty good analogy over the years that students enjoy. You have these PowerPoint slides. If you copy and paste this YouTube video, this still pops up, which is another explanation of the insides of a computer. So at the very lowest level, computers speak in ones and zeros. Ones and zeros are called bits, a binary two-state digit. Then we said, okay, we got to make these things be able to work for us, for business people. So we're going to start using codes and instructions. And those codes and instructions are called, as mentioned, software. In the very simple case of let's represent the letter C and A and T, so I can spell cat or text the word cat to my friend, along with other words, of course. ASCII, the American Standard Code for Information Interchange, is a code that uses 8 bits, 8 ones and zeros, to represent every character on your computer keyboard. So 00110010 here represents the capital C. The second sequence represents small a, and this third sequence represents small t. So each letter on your computer keyboard is called a byte. And so cat here needs 3 bytes to be able to store it. It needs 24 bits to store the same word, cat, because each of the letters is 8 bits. Does that make sense? So one character, letter C, is 1 byte, and it's 8 bits. From there, you can answer all sorts of questions like this. How many bits is the letter A? 8. How many bytes is the letter A? 1. How many bytes in RFID? So bytes. 1, 2, 3, 4. How many bits? 4 times 8 equals 32. Why do we worry about that? Well, you need some sort of a context of your capacity, both storage capacity and transmission capacity. Hardware and software is almost always spoken about in bits. You have a 10, in bytes. You have a 10 megabyte hard drive. Mega here means million. K is 1,000. M or mega is million. Giga or G is billion. And tera or T is trillion. So I have a 128 gigabyte flash drive on my computer here. That means I have 128 billion bytes of storage capacity. Telecommunications, if you're talking about your internet connection or your modem, they almost always give you those capacities in bits. So you'll learn that if you have a DSL modem or you purchase cable from Comcast, they'll tell you that you can get a 50 gigabits per second, GBps. So they're talking in bits, so you have to keep in mind that they are different by a factor of 8. In this unit, we're talking about hardware and software. So computers go from small to large, and it's useful to know some things as a manager of tomorrow about the categories and the evolution. So starting from the smallest is what's probably in your pocket or your backpack, your smartphone. And these are one of the biggest advances, one of the biggest tools that you will have at your disposal for coming up with creative solutions to business problems. You can basically assume, as we discussed in the prior unit, that everyone has a smartphone. So your clients, your customers, your employees, and you can connect to them in different ways, improve your processes with them in different ways, and solve problems in different ways. So it's essentially having a computer in your pocket or your hand. That's, of course, a very good thing. Moving up, you have tablets. They're a little bigger. Sometimes, we want to use them as a little computer, a little easier to type or whatever. That's an iPad, is obviously the most popular tablet. And then a laptop or a desktop is called a notebook or a desktop, which is also both called a microcomputer. Smallest type of computer, and most of us will have one of those in addition to a phone and or a tablet. Here's a picture inside a traditional computer. This is a third picture now. We saw the first one with squares and arrows, then a more realistic picture, this is a similar thing. There's the green motherboard. We have the RAM plugged in, and we have the CPU plugged in. Why show this picture again? To talk about the CPU and something called clock speed. Students will ask me, Dr. Downing, what sort of computer should I purchase? What sort of laptop should I purchase? My short answer is that computers have become commodities, which means you can buy many different types and they're very similar. A Dell, an HP, that brand doesn't mean much to me in the differences at this point, but I am interested primarily in two things: the size of the RAM, so the size of my desktop, and the clock speed, which is the speed of the brain. So you know what this is. What is this? Along with the clock speed, you're given a word size on a chip. So you may have heard the term, hey, is your computer 32-bit or 64-bit? Well, that's the CPU's capacity. It's how many ones and zeros can be transferred back and forth from the CPU to the computer per second. So megahertz is millions of cycles per second, and if you put a G on that, gigahertz is billions of cycles per second. So if you had a 1 megahertz computer that was a 16-bit chip, you could transfer 16 million ones and zeros per second. So obviously, the faster your computer can do things, the more capacity you have to watch large videos, listen to songs, do things simultaneously, etc. So looking at this question, how many bytes can a 1 gigahertz 32-bit chip process per second? Well, we know 1 gigahertz would be 1 billion times per second. It can transfer 32 ones and zeros back and forth. So in 1 second, it can transfer 32 billion ones and zeros. But ones and zeros are bits. Kind of a tricky question. To get to bytes, remember, 8 bits make up a byte. So we would divide by 8. So 1 billion times 32 divided by 8. In this case, 4 billion bytes per second. Obviously, a lot of choices. If you see something like duo, it means a dual processing, parallel processing. That just means faster. You have 2 brains working together. Quad is 4 brains working together, roughly 4 times the capacity for your CPU to think. So you want to keep just a general track of what's going on as a manager. And they all work together. The brain, the operating system, we'll talk about what that means more formally in a second, and the software. And you don't want to get bottlenecked. So you got to make sure to have them work together. Meaning if you have a 32-bit chip, you don't want to run a 16-bit operating system, because that chip then will have capacity that that operating system, whether it's Windows or OS X, wouldn't have. So you want to keep these in line. So again, still talking about microcomputers. They're often the client. They connect to a server. So a client is like a terminal. So if you log into Facebook, or if you log into a cloud, which Facebook is, you're using your laptop as the client, and Facebook is the server. All your friends' photos, your photos, all the information on Facebook is stored on their server. They have many servers. and you're the client. You're participating. You're logging in so you can see it. The next level up of computer is a mini computer. It's a little bit bigger, a little bit faster, and a little more expensive. These classes are increasingly being blurred, and the bigger, newer companies of today, Google, Facebook, Amazon, they just use a bunch of notebook computers, a bunch of desktop computers tied together, connected. So they're just using stuff you could purchase at Best Buy to run Facebook and Google. So why do we talk about something like a mini computer? Older companies use minis and mainframes, so it's just a little bit larger, does a little bit more work. It's just a term you need to know. We're going to learn about SAP in this unit, which is an ERP application, and most of those will run on a mini computer. Mainframe is the biggest, fastest, and the most expensive, and in many cases they're in their own room, they require special cooling, etc. So oftentimes they're the host, which is also the server in a networked environment, as opposed to the client. So, should we even bother talking about these if the biggest companies are just tying together a bunch of desktop computers? And yeah, we are. There's a lot invested. This is a word we use a lot in OMIS 351. The word is momentum. When something has been done a certain way for a long time, you can't just pivot and decide not to do it at all anymore. Over $2 trillion is a lot of momentum, over 100,000 machines. So you're not just going to walk away and say we don't need to understand mainframes at all. They're very much a reality in business. IBM was a big company that made them. COBOL is a software language for mainframes, and EBCDIC is a code system similar to ASCII. So here's a picture, a host or a server, and clients connecting to their resources. And we've defined cloud. Cloud computing is moving computing processes or resources onto the internet. So if you don't want to purchase all the hardware and the software, you might just want to connect to the cloud, which is provided by someone else. And of course, this is becoming increasingly popular in business today. And here's Moore's Law right here. Doubling every 18 months, the power of computers. And you might just look at a slide like this and say, okay, I'll just look at that. But I want you to pause for a second and take a moment to really understand how incredibly powerful this law is. Gordon Moore was one of the founders of Intel. He coined this law in about 1975, and it's stayed true, which is just incredible. To bring this home, I often tell students, how about, let's say there's 2 months left in OMIS 351, and I just say to you, you know what, I can see you're tired of this class. How about you just buy an A? And to buy an A, with 2 months left in the class, you have to pay me 1 cent tomorrow and double the payment every day, just for 2 months. So as you can see here, the first day your payment would be 1 cent. No problem. I've made a formula doubling that. So your second payment would be 2 cents. There's the formula for total. You will, after the second day, you'll have paid me 3 cents. This seems like a good deal. You only got to go down to 60. 2 months remaining in the semester. No questions asked. You get an A. You don't have to study. You don't have to deal with me at all. So you see, okay, it's doubling every day. So the seventh day, it's 64 cents. You can afford that, right? Your total is $1.27. Well, let's go down through the end of 2 months. Not very far from here. When you see that, it means the numbers are so big it doesn't fit in the column. I can't even pronounce that number. There's your final payment to me. You can see why this would be a good deal for me. My goodness. What's the point of this? The point of this is if you double something every certain period, it gets very large very quickly. So that's how these computers are doing these amazing things for us now. They've just advanced so rapidly. I believe there's a question somewhere about what's the point of that story. It's just showing how powerful this law is.